How's everybody feeling today? Are you guys excited about Box Day Zurich second edition? Yes? You had coffee? Yes? Ready to keep learning? Excellent. All right. So, by the title, I'm going to discuss a few Java-related projects, but I have a challenge for you. So here is. The challenge is, how could you write an application that consumes a REST API? Now, I decided to choose specifically a REST API because many of us have to deal with REST in one way or another. I know that there is also now a good number of people dealing with the binary protocols and some other different communication mechanisms, but REST is still with us, so we're going to use it because it's kind of like the basis. And of course, we had to do it with Java. The way that we need to do this, we have to create components that are reusable, that are highly testable, and in such a way that also we don't have to write that much amount of code. You might have some ideas of how you could this, right? We like to tinker, we like to engineer our stuff, okay? So without any further ado, these are the libraries that we're going to see today if the clicker works. You might recognize some of those already. We're going to see some libraries for creating the production code, and we're going to see also some libraries for testing the code, because it's not enough to just write code and then put it out in the open. We also need to test it. All right? Disclaimer. Well, this thing actually doesn't work. All the libraries that we're going to see today and all the projects are open source. You can use them as is. You can use them right away, and you can put them to work on your daily projects without any problem at all. Also, most of the libraries, if not all of them, we have used them before in our customer projects, so we have plenty of good experience of when things actually work and when things actually break. This is part of the reason why I would recommend you to have a look at these libraries. And my goal for today is that by the end of the 48 minutes that are left, you'll feel like this. And you feel like this when working with your code, all right? Okay, so my name is Almiray. I work for this company called Canoe. We are one of the sponsors of this beautiful and excellent conference. I come from Mexico, and I'm also a member of the Groovy development team and co-creator of and co-founder of the Griffon framework, Java 1 Rockstar, Java Champion, yada, yada, yada. That means I kind of know a few things about Java, and I want to share my experiences with you. I also would like to have, if possible, a very interactive experience with you. So at any time, if you have any questions, please let me know. Hopefully, we have time at the end of the session if you have more questions, and I'll be here for the rest of the conference. Just grab me by the hall, and then we can continue the discussion. Is that okay for you guys? All right. Okay, so let's go back again to the challenge. Again, remember, we want to build a Java-based application that consumes a REST-based API. I'm here to do it in a way that is fun, that is concise, that is small enough, and that is highly testable. Now, I'm also going to add a new bit to this challenge, is that how many people here still develop applications for the desktop, Swing or JavaFX? Just a few hands. Well, the application that I'm going to showcase today is built on top of JavaFX, just for demonstration purposes. But everything else that you're going to see, you can put it to work on the web, on the server, on the client, on mobile. It doesn't matter. The libraries still work on those environments. Okay, so for the REST API, I chose to use the GitHub API just because it's well documented. Many people have to use GitHub in one way or another. If you go to that URL, that's version 3 of the API, then you can learn everything that is out there to learn about this API. It's very well documented. Because it's so big, we're only going to deal with querying repositories for a particular user or organization. Actually, we're going to use organization. So here it is. If you go to that URL, you see the description of what is the payload that you need to send to that API, and what kind of payloads do you get as a result. And based on that, we're going to consume that information. So if we issue a GET call to that URL, which is parameterized, we can get a JSON payload with all the information. And this information actually, depending on the size or how many repositories are there for that organization, may be paginated. And the pagination mechanism in GitHub API, which is also described there, uses HTTP headers to figure out if we need to go to the next URL or the previous URL, if this is the last or the first or whatnot. So we need to understand, the application needs to understand how to deal with headers and consume the next URL, all right? So when we issue a get call like this one, we get a JSON payload like this one. Actually, I just shortened it because you get like 40 different properties associated with a repository. For our purposes, we only care about 4 of them, and you get all this in a big JSON array. What else we're going to need? I guess that in this time and age, it will be very, very hard for people to come up with a new solution, a new project where they don't use any form of dependency injection. It doesn't matter which tool, which library, which framework you use, there's bound to be some dependency injection. Of course, we require an HTTP client and some kind of REST capabilities on top of that one. We need to figure out how to do JSON mapping from a JSON payload into a Java object. Very likely that we're going to deal with POJOs, and that means getters and setters, and that means yada, yada, more code. We want to remove that boilerplate code. And finally, because I said we are going to show or use a desktop application, you have to deal with concurrency. Because for those that raise your hand when you say, I still do or did desktop programming, you know there's one rule that we should not break. Everything that is UI related, painting on the screen or accessing properties of a widget, must happen inside a specific thread, UI thread. Everything that is not UI related, like querying the database or issuing a network call, should happen outside the UI thread. And because it's easy to break this rule, there are so many bad swing applications out there because nobody cares about threading, but we are going to care about threading, all right? You can get the code that I'm going to show today from this URL. Don't worry, the slides will also be available to you. Everything there is open source. Under GPL, you can read the code, you can study the code, you can take the code, you can use it if you want to. So let me show you the application in question. And I'm going to run, I actually have 5 different versions. And you can run it directly from, once you clone the repository, if you use Gradle, just use the Gradle wrapper, and then you get it. Let's see if we can get a little bit bigger. Yeah, perfect. So if I give it a name of a repository, notice the nice thing about JavaFX binding and whatnot. I can tell that when this button is enabled or not very easily. If I load this, if I click here, it's going to load the first page and then follow the other pages in case they are. And I get the number of how many repositories. But notice that also, once information starts to stream in, if I got network, come on. I did test this before. Let's see. Network? Yes. There is. Oh, no network. Come on. No worries, because this goes a part of the demo. If when you need to test this thing and you don't have network access to the real deal, you need to still find a way to test this thing, right? Let's give it another try. And if it doesn't work anymore, there we go. You see that? And I was too fast, and we got 245 repositories. There are many things that we can do with this application, but that is enough. So that's basically it. Okay? So the first thing is that we're going to go with dependency injection. And does anybody know what is the name or what is the number of the JSR that standardizes dependency injection in the JVM? Yeah, right. JSR 330. It's a very small JSR. It's only 6 classes. Actually, most of them are interfaces. So what do we do with dependency injection? Well, you define your API in many different ways. Say, I prefer to do interfaces first. So let's say we define an interface like this. I put that thing in red because we're going to see it in just a moment, what that thing is. But we need to create an instance of this interface, or actually create an implementation of this interface and inject it into some component. You know pretty much this already. Use add inject. One of those annotations come from JSR 330. And then what needs to happen is that the type that you are injecting and the type that requires the injectees must be handled by the dependency injection container, right? So in this case, what I want to showcase is Juice, Google Juice. Why? Because Google Juice is the reference implementation of JSR 330. Juice gives you the capability to define bindings in a programmatic API, a programmatic way. Here I have defined 3 bindings. One is a source class to a target class. The second one is to the source and the target class are exactly the same app model. And the third one, that is a lazy binding. It's a provider. In terms of a Spring, that is a factory bean. The bean is only created by the moment that you actually need to access it. And there are 2 other more kind of bindings that you can have in Juice. One that is really good is binding to a constant value, which actually make use of that in the source code if you look at the repository. Why? Because during production, I want to bind to the URL of the real GitHub API. But during testing, I want to bind the URL to a testing value. So the reasons to use Juice is because it's the reference implementation of JSR 330. It gives you, it's kind of a smallish dependency framework. It's extensible. You can listen to changes, or when an instance has been created by the dependency injection, you can react to the life cycle. The one thing that I don't like specifically about Juice is that if you are expecting an injected type to react to an annotation, for example, post-construct or pre-destroy, Juice doesn't give you this out of the box. But you can get it if you add an additional extension to Juice. It's called, I actually don't recall what is the name, but it's in the repository. So you just put it in the class path, and then boom, now, if you annotate a class with post-construct and pre-destroy, then those lifecycle methods will be invoked at the right time for you. If you happen to use Juice, then you get another bonus Java library, which is called Guava, Google Guava. Guava was created many years ago out of frustration of missing bits in the standard Java library. And it gives you new collections. It gives you functional capabilities and that are not found in JDK 7 or prior. How many people are using JDK already? Some hands. Well, kind of half of you. Good. If you haven't migrated to JDK 8, please do so quickly, because JDK 9 is supposed to come out this year. And then migration will take much, much longer. It's very cool, and it's actually, if you don't move for the syntax, then just move for the JVM features, which make it run your applications much faster anyway. So if you, for some reason, can't migrate to JDK 8 still, and you want to use functional programming, then Google Guava is a nice option for you. But if you do not use Juice, it's probably that you have encountered Spring. And I know that Spring has a huge portfolio of projects, and for now, I'm only going to concentrate in one project alone, the first one, Spring Framework Core. This is the component, this is the library that will give you dependency injection, but it will also give you capabilities to write better tests. It gives you capabilities for having better internationalization. I don't know if you know, but the default message format coming from the JDK is not thread safe. But the one provided by the Spring Framework Core is. So if you have to deal with internationalization often, then have a look at this one. You also have access to serialization. Creating JMX clients with the Spring Core is so, so easy. It should not be allowed. It's really just a couple of lines, and that's it. Also, it's just exposing also JMX beans. The JDBC template and validation and whatnot. This is really cool. And then, of course, once you get into Spring, you might want to try out other projects from the Spring portfolio. Next one is reducing boilerplate code. Now, most people are aware of the Java Beans conventions. How do you write a well-behaved POJO? Do you have to have a constructor with parameters? No. You have to have getters and setters for each property that you want to mutate? Yeah. And you have to have a proper implementation of the equals and hash code. How many ways are there to implement equals and hash code? So many different ways. What is the correct way? That's kind of hard, right? If you follow just blocks effective Java, there is a good algorithm there. So we had to take care of these constraints. Wouldn't it be better if we had some tool that can generate all these things? Yes, of course, the IDE. The IDE can generate source code using macros and templates. But the problem that I see with this is that once the IDE has generated the source code, you are the ones that had to maintain that source code. It's okay to rename a property. The IDE will help you. It's okay to add a new property. Yes, the IDE will have to regenerate all those methods. What happens when you need to remove a property? It's a little bit more of elaborate things that you have to do on your side. So what if instead of generating source code, you were to generate bytecode? Wouldn't it be better if we keep our source code small and concise, and have the compiler do the heavy lifting instead of us or the IDE. And that's precisely what Project Lombok is. Project Lombok hooks into the compiler process and will generate the right bytecode for you. The only thing that you need to do is apply a set of annotations to your source code. So what we're seeing here is the Java object, the POJO, that is going to represent a repository that's mapped to the JSON output coming from the repository query. So here we have actually two libraries. One is Lombok, and the other is Jackson, which is one we're going to use for the mapping. So what Lombok does, in this case, the add the data annotation, it says, when you put this in a class, for every property that I find, or actually field, I'm going to generate a pair of getters and setters. If you make it the final field, then I'm only going to generate a getter. And if it's final, then I have to initialize that in a constructor. And it's going to generate the constructor in the right order. It will also generate an equals and hash code implementation for you. And it also will generate a toString implementation for you. And you can tweak all these values. You can put a protected access or visibility modifier instead of private. You can have a fluent interface design for the getters and the setters if you want to, actually the setters. That gives you many options. In the case of Jackson, remember that the JSON payload will return like a buttload of properties. We only care about 4. If we annotate our class with that annotation, JSON ignore properties, ignore unknown, then it doesn't matter if the JSON payload has 40 properties. If I only have 4 that I'm interested in, those 4, then Jackson is going to map only those 4. And also the other thing that it looks a little bit weird right there when we got this annotation at setter, that's Lombok. When we got another thing that says ampersand __, and then a Jackson annotation, JSON property full name. What we're saying is Lombok, generate a getter and a setter. And that annotation, JSON property, you're going to put it on the setter itself. And what we're saying is that the JSON property is mapped using a snake case convention. But our Java property uses camel case convention. This will do the right thing for you. There's nothing else that you need to code. Now, Lombok is also happy, here's another version, who likes to use the builder pattern to have immutable objects, but being able to create objects as you go. That's the builder pattern for mostly. Here it is. You don't need to create the with something, and then just apply the builder annotation. The most easiest way is to a static method. You can change the name of the method. You can put it on some other method. And this will create the builder for you automatically. It creates a new class for you, actually, and all the bytecode. In order to use Lombok, you must have, here's another example, when you can have inheritance. The base class has nothing, and the child class has annotated with that data, and also says, I'm going to call the equals and hash code of my superclass on my own hash code and on my own equals. That's basically it. That's one way that you can configure this. Now, Lombok is very powerful, hooks into the APT processor tool, which was released in JDK 6. So if you're using JDK 6 or upwards, there's no problem. You must use or you must apply a plugin in your IDE of choice. If it's IntelliJ or Eclipse or NetBeans, I think NetBeans doesn't require one. But both IntelliJ and Eclipse will require an additional plugin because the new methods added by the bytecode, they had to be visible for you at source time or development time in order for you to call those things, right? So that's the whole thing for the plugin. It's very easy to install, much more of a problem. And Lombok is extensible, but I wouldn't recommend you, as a regular developer, you don't need to extend Lombok because many of the annotations or much of the behavior that you need is already provided by Lombok in order to generate well-behaved POJOs, the builder, values, a sneaky throw. I'm not so sure if it also has an annotation for add immutable, for generating really immutable classes, but we can give it a try. And one very, very important thing, do not forget to enable the annotation processing tool in your IDE. If you do not, then no bytecode is going to be generated. If you're using Maven or Gradle, technically you don't need to use the APT processor plugin. You just use it in case that you want to help your IDE with the generated source code. Actually, no, not generated source code, generated bytecode. How are we doing? So far, so good? Okay. I tend to speak very fast when I get excited, and trust me, This gets me very excited because I use most of these libraries every single day on my daily work. So when we're dealing with behavior, sometimes we want to monitor the state of our application. And the easiest way to monitor where we're going is by logging. And I had to say it already. There is no good logging framework for Java. There is none. But out of the other options that you have access to, SLF4j is perhaps the one that gives you the best options. Because, actually I selected because it's widely used in the open source community, but because of two features. One is that if you consume an API that relies on Apache Commons logging, or Java UT logging, or Log4j, or something else, you can funnel all those calls into a single API, the SLF4j API. So you only need one single file to configure the logging levels for everything else. And the second thing is that you have variable arguments for the login methods. Because you probably have seen this. When you do log info and then pass a message, if the info level is not enabled, then, well, the log doesn't come out, right? But you pay the price to create a string if that string happens to be an expensive one. It's not just a simple string, but concatenations and whatnot. You have to sprinkle the code with guards, like if log info is enabled, then log info. But if you have variable arguments, then simply say log info, the format of the message, and then the arguments. And if the info level is not enabled, then no worries, nothing happened. New versions, I think the SLF4j, and there is another one, Log4j2, besides variable arguments, they also support lambdas, message suppliers, like JUnit 5 also. So you don't pay the price of creating the message if the level that you are targeting has not been enabled in configuration. All right. Now we're getting into the subject proper. How do we do HTTP in Java? Most of you, I suppose, are familiar with Apache HTTP client. It's been there for ages. Does HTTP client support HTTP2? We should care about HTTP2 now, especially because JDK 9 will not come in with a baked-in HTTP2 client. It's been rolled out of that release. I don't know why. But HTTP2 is the future. So we have to think about that. And how many ways are there to deal with REST, considering that if you read the paper or the description of how REST should behave, there's only one way. So how many ways can we do this thing? Just one way. Why do we have to implement it very differently for every single project? So I will propose to use OK HTTP. It's a small and fast HTTP client created by the people from the Square. They write software for Java Desktop and Java Android. Well, Android is not Java, depending on who you ask. So it's tiny. The memory footprint is small. So if it works on a mobile space, it should work on the desktop, and certainly can work on the server. So this is basically how you do. You create an instance of this thing. It's configurable. I guess we only create a simple HTTP client. Then you create a request object. You can define headers. You can define attributes, cookies, and whatnot. You can also define interceptors if you want to enrich the request and the response. Then issue the call. You get a response object. You can query for the status message. You can query for many things. And, of course, you can query for the body. And once you get the body, you can transform that using the right transformant depending on the content type, right? Easy as that. So I have found OK HTTP to be very, very fast, very tiny, and very extensible. Next. How do we add Java on top of HTTP? Because it's one thing is to say, yes, let's go into issue a network call, and then I have to deal with the headers, and then do the transformation of XML or JSON myself. No, it would be better if we had a Java API on top of that complexity. But again, how many times can we implement the way that REST behaves so that we can map it to a Java class? There's only a handful of them, and we don't need to do it ourselves if we let Retrofit do the work for us. So what Retrofit allows you to do is you define your REST API, your client, using an interface like this one. So we're just going to query the repository. So the first method says, here's a parameter, that's the name of the repository, And as a result, I get something, it's a call, that is a type of retrofit that will tell me what is the response and many other things that I may be interested, again, low-level HTTP things. And I get a list of repository objects out of that. Nice. And if the headers contain a link to the next URL, I can grab that URL and issue the second method when you say repositories and I paste an URL, and also get a list of repositories. So with these two methods, I can do the pagination. Okay, but what else? This is only giving me the access to the parameters and the types. What you do is that you create a Java lang reflect proxy based on the Retrofit builder. The Retrofit builder takes the URL, takes some configuration. One of them is the URL, where you're going to point this thing to. Then some configurations like factories. In this case, we're using the Jackson factory so that we can transform JSON payloads into Java objects using the repository class we saw before. And then we build that thing, then create a proxy based on the GitHub API interface, which is the one from the previous slide. You see that? And now that we have that object, we can simply call methods on that thing. And under the covers, there it goes, an HTTP request, passing everything. And then when it comes back, if the response is successful, then it will transform the body automatically into a list of repository objects. And boom, we have only to deal with Java objects. All the REST and all the HTTP complexity is completely hidden and managed by Retrofit. It's quite extensible, and under the covers, Retrofit uses OK HTTP. So you can use HTTP 2 as well. How do we handle multi-threaded code? Because you remember that if we are building a JavaFX application, everything that is UI must happen inside the UI thread, and anything that is not happens outside. So issuing a call like the repositories on the GitHub API must be done in a background thread. And once the results are ready, then we have to get those results back into the UI because we display them on a list. Or while the results are being computed, if we have intermediate results, we want to push them into the UI as well, right? So we have at least two threads that need to coordinate one another. How do we do this? Well, if we take an inspiration from the JavaScript community, they came up with a solution a few years ago, which actually was born many, many years before in the Swing Worker, which was inspired by some other people before that. So what I'm saying is that the concept of promises is not new. It's just a new name. So here is JDefer is a library that allows you to do exactly that, jQuery-like promises in Java. And that goes back to remember that red side that we saw earlier on, that promise object? So what we're seeing here is that when we issue a call like that, repositories with a name, we get back an object that is able to handle whenever a result comes in. That result will be a collection of repositories. If there is an exception or an error, then the second type is what we're going to receive. JDefer allows you to catch any kind of type, not just throwable, not just exception. And if there happen to be intermediate results while you're doing the computation on the background thread, then the third type is what you're going to publish. In this case, I'm not publishing anything. But there's another version of this API when I publish a repository. So every time that I read something in the background and there's a repository, it will get pushed automatically into the UI, just like we did in Swing Worker in the previous days. So there are two ways that actually two things that we need to do for working with a promise. One is how do we create the promise object itself? We need a background task. And the second is how do we consume? Here is the case on how we create the promise and the background task. There's a new type out there called Defer Manager from JDefer. This is basically an abstraction on top of Execute Service that gives you many benefits. One of them is to schedule a background task. That thing inside the Lambda expression is our background task. So what this thing is doing is issuing the network call, and if it's successful, then returns that list of objects. Notice that we simply say response.body. Why? Because our call object returns a list of or a collection of repositories just like that. If not, then we simply throw an exception. That runs in the background, and when that is ready, we consume that thing in this way. Say, for example, this is a controller component that we have some series of configuration settings. For example, if we want to limit the amount of repositories we want to query, then we can specify in that way. We issue the call to the promise that returns a collection of repositories, may throw something, and in this case, the third type says repository, so this one cares about intermediate results. And notice what we do with the promise. The progress callback says, whenever a repository comes in, I'm going to invoke that method. That is a method reference. Okay, so I'm going to add that thing to a list. Good. If by any chance the whole thing fails, then I'm going to handle that using another method reference. Simply print out to the system error. But regardless if it was a failure or if the whole thing succeeded, I always want to do the following thing, which is just trigger a change of state, so that in the case that you saw earlier the application, the button for load was disabled when this thing was running, and when this thing finished, the button for load was again enabled. And if there is a failure, well, of course, the button for running again has to be enabled, right? That's the whole reason why we use always. JDefer then gives you the concept of promises inspired by jQuery. The last release was made 2 weeks ago, release 1.2.5. And it's Java 8 friendly. As you saw, you can use expressions for creating the background task, and also for the callbacks for done, progress, and everything else. It's pretty good. There is one caveat though. Promises, and in this case, and the background task they are only useful for one-shot executions. You can, doing some interesting things, read the response for the first query, then figure out if you have more information in the headers and continue on, right? But there is no way. This is all or nothing. Either you finish with the task or you don't. There is no way that you can stream in results, okay? But for that, we will have to look at reactive programming, which is not other thing that reactive programming is basically event processing, property chain listener, a property chain event. Again, desktop, but with the different classes and a little bit of different names. So it's basically the same idea. You're just processing events in perhaps in an infinite amount of sources of events. So here is RxJava. It's probably the most well-known out there. It's not the only one, but it's very easy to get started. So what we're going to do, instead of getting a promise out of our service call, we're going to get an object type observable. If you're using RxJava 2, then you're going to get probably a flowable. What's the difference? That a flowable gives you access to back pressure. What does back pressure mean? If the producer is creating too much data, much faster than the client can consume it, then the client is going to get bogged down. So what the client can say is tell some information to the server to wait a little bit or buffer out the results so that when the client is finished with the current workload, then it can continue with the next one. So that's basically back pressure, and only the flowable type will give you this, observable no longer. And the rest of that is that we just enhance or continue adding more behavior on top of that observable. So what we're saying is that we'll have a default timeout of 10 seconds. If we don't get any answers within 10 seconds, then we're just going to fail. And when we subscribe, we're going to change our state. And when we finish, it doesn't matter if it's, again, success or failure, we're going to change the state again. When we subscribe on, that means that's the background thread that we're going to use, because otherwise we're going to use the same thread that you subscribe on. That will be bad, because that won't be a background thread. When we subscribe, any object that gets intermediate, the intermediate result is going to be added to that list, and it happens to be an error. In this case, we're just simply going to blow up with a print stack trace. And then boom, we just subscribe. That means now we have a channel. We're listening to these channel events, and whenever they occur, we're going to see the repositories being pushed into that list. Can we use Retrofit and RxJava together? Yes, we can. There is an extension for that. And what you have to do is, besides adding a dependency, you have to modify your API. So instead of returning an object of type call, then you get actually an observable of a response, that is Retrofit, of the list or collection of repositories. And notice that the parameters for the other things look exactly the same. The only thing that we need to change is the return type. If we are not doing pagination, then this is all that we need to do. But because we had to do pagination, I'm going to show you what can we do to resolve that. The other thing that we had to do for the builder, for the retrofit proxy, is that we had to add one more factory. Besides telling it that it needs to use Jackson to do the processing within JSON and Java, now we add the RX Java adapter so that it knows that it can work with observable objects, not just plain values. So doing pagination can be done in this way. There may be other ways. Basically, what we're saying is that, and this code is actually, again, also in the repository. We issue the first call using a Lambda, and then we concatenate that with the results coming from the second one. So we're going to use the second one. Notice that it takes an argument, links, and from that we're going to extract the URL. So how do we actually deal with this? What happens is that the first call is going to give us a list of repositories. And we're going to put that in observable. Think of observable as a flow of repositories only. There's no list of repositories there. But for every page, we're going to get a second or a third list of repositories. Is there a way that we can concatenate or flatten the list of repositories into a single thing? That's exactly what the flat math operator is doing for us. So for every page that we process, we are going to concatenate the list into the previous one, so that at the end, we see that we only consume an observable of repository, not an observable of list of repository. That's basically it. Notice that the code will eventually inspect the headers, and the link class, which is a very basic class that knows how to read the headers, if it finds the next link, then it's going to use it from the previous Lambda and then go on until recursively we can find everything. All right? So RxJava is quite useful. There are plenty of documentation and examples out there that you can learn from. And InfoQ just put out an online magazine that you can get for free on this particular topic. Actually, I wrote an article on how you can test RxJava if you are interested into this one. Okay. We are almost done with production code and almost getting ready to get into the testing code. But one final thing is, so far the examples I have shown say that if I got an exception, I simply print out the stack trace, right? What if instead of doing that, we pop up a dialog saying, oh, there is an error, and you can fix it by this and whatnot if possible. The controller class, if we want to be purists, the controller should not have anything to do with UI at all if you follow the MVC pattern. So how does it create the dialog, which is view? Can we have some way to have the controller component communicate with the view component so that the controller doesn't know the view directly and vice versa? For this, we're going to use an event bus. And the one that I suggest is Ambassador, which is quite good. If you're using Guava, there is also another event bus in Guava. But this one actually has been benchmarked to be much faster. And if that weren't not the case, which is luckily it is, it still provides a good, much better API than the event bus that you find in Guava. So this is how we define a publisher. So it's the same controller class that we saw before, and instead of just printing the stack trace, notice that we simply say publish an event. And actually we're saying publish async, which means post it, and I don't care. You can also say publish, and that will wait for other consumers to finish consuming the event, and then you continue. In this case, simply say just publish, and somebody, hopefully, will handle the event. You can send any kind of object. In this case, I decided to create a throwable event, which is a class that I created using Lombok. How do you consume this? Well, you have any class that provides a method annotated with the @handler annotation. The name of the method can be anything you want. The important thing is the type of the argument. Notice in this case is a throwable event type. So when this class, notice using post-construct and pre-destroy, gets registered with the event bus, once it has been created by the dependency injection container, then whenever an event happens, this event handler is going to be invoked. Now in this case, you don't see the code, but in the repository, you will see there's enough code for this to create a JavaFX dialog. And I didn't show the example, but we'll see in just a moment in testing. So now you know how to produce events and how to consume events. Ambassador is quite good. There is one caveat. The author doesn't work so often in the code these days. So if you find a bug, just be careful because the fix might not come out as fast as you may expect. This being said, Ambassador is quite good and to be put into production. Actually, at Canoe, we have a couple of customers that where we're using this thing, we haven't found any problems at all. So now that we have said this, let's move into testing. And we got less than 10 minutes for this one, so we'll see. How many of you were at Sam's Brannan JUnit 5 talk an hour ago or so? Okay, so you know that you can parameterize a JUnit 4 a JUnit test. And there are some ways to do this in JUnit 5. But if you are stuck again with JUnit 4, there's one particular problem with parameterizing JUnit 4 test cases. You can only parameterize the same method. If you have multiple methods parameterized in the same test case, they have to have the same number of arguments and the same type of arguments. There's no way that you can have different types. So that means that you have to have different types and different cardinality. You have to have multiple test cases. Well, if you happen to use JUnit params, then it's a matter of using the right annotations, and now you can go back to a single test case when you have all the relevant scenarios packed in the same thing, and then you go. You can supply the arguments directly in the annotation. You can give it the name of a method that supplies the values, or you can even give it the name of, or actually the class name of the data provider, if you will. It's quite good. Unfortunately, you have to use a custom runner. So if you're running another test, a test case with another particular runner, this might not work for you. But I have found this to be a good replacement from JUnit 4 standard parameterization. The next one is, do any of you guys do TDD? All right, a few hands only. So we know that we have to test our classes in isolation, and for that, our collaborators have to be as lean as possible. For this reason, people advocate the use of mocking. Out of the many things that you can see out there to do mocking, I would recommend you to have a look at Mockito. It's probably the best library that you can find out there. And of the many things that Mockito can do, it will allow you to mock final classes, something that other mocking libraries will not allow you, just in case that you happen to have a final class that needs to be tested in some way. What we have here is the sample controller and the sample model are real classes, but the sample service is the mock collaborator. And then in the expectations block, using, this I really like, a DSL for defining our expectations. When we say that method gets invoked with such argument, whatever that value input is, notice that we're also using JUnit to parameterize that method, then we return certain output. In the when block, this is where we exercise our stimuli, so the controller, and then we verify that the controller did the right thing, and that our mock also was invoked, in this case, only once, and if we pass that argument, then it should be fine. If it were invoked once, but the argument was different, then this test will fail. Mockito gives you support for this kind of testing, so stops, which means I'm going to give you a canned result. Whenever you ask me for something, this is what you get. A mock is a much stricter one because it's not only that you call me, but you call me in the right amount of times, and you also call me in the right order. And you can have spies. Spies are real objects for which there's a partial implementation using stubbing or mocking. If you happen to be using JUnit and use, and you want to use Mockito, then just apply Mockito like that, or use Jukito. Sounds cool. Now, what this project does is it brings you Juice and and JUnit and Mockito. You can inject objects into or instances into your test case, so that's one thing that it gives you. But the second thing is that if you do not provide a binding for a particular type, then it's going to be mocked automatically using Mockito for you. So what this test is doing is pretty much similar to the other one that is not parameterized, by the way, because again, custom runner. What this test is saying is that I didn't provide a binding for the service. So that service is going to be automatically mocked for me, I can specify the specifications just like we did before, and notice that the test code is pretty much the same. Now the advantage is that the mocking is done automatically by the dependency injection container. So if you happen to need that mock collaborator more than once in 2 places, it's going to be the same mock. It's going to be safe. Next, if you're feeling adventurous and you want to test out other JVM languages, I would suggest you to have a look at Groovy. And if you do, then you have access to Spock. Spock gives you parameterization and mocking capabilities, much like Mockito and the other projects that we saw before. Do you see something weird about this code, besides that it's Groovy code? What about the method name? The method name is a string. If you didn't know, the JVM allows you to have any type of characters in the method name. Java, the language, is the one that doesn't. But Groovy gives you back that capability. What does it mean? I can actually have a multi-line string as the method name, so I can be very expressive of what I want to say with this method. That's one of the many things that I can do with Spock. We have an automatic mock right there in the middle. We're mocking the service. And notice the parameterization. We are actually using a list of values. That left shift operator, we got operator overloaded in Groovy. Yay. We are just giving the amount. That's just one of many ways when we can parameterize a particular test. Okay, next one, we know we're dealing with concurrency. How do you test concurrency? When you know for a fact that you have a background test and you need to wait until the background test is finished, what do we do usually? Thread.sleep, catch interrupted session. Hopefully, we give it the right amount of timeout. And if we give it too much, the test is going to be very slow, right? What if we had another way to test this? What if we had conditions that can wait at most certain timeout? That's exactly what our utility does. So you can give it a condition using lambdas, on handcrest matchers, on something else, so that if, in this case, the method that we're calling the observable, when we call controller.load right there, if we wait more than 2 seconds, the test is going to fail. If we didn't get the result in this time, the getState method, if it's not equal to that value, that means that it's taking too long, so failure. But if it does, then we continue and then we do the right assertions. This will be much, much better than doing thread.sleep, and hopefully that we got the right amount of timeout. And finally, I said something about network. Would it be okay for us to ping the GitHub service every time that we run a test case, like an integration test case or a functional test case? Do we expect our servers to be always ready when we're going to test something? Sometimes we can. Sometimes we shouldn't. So what if we are able to run a fake server? Set up the appropriate constraints in the request so that if the request is matched, then we can reply with a specific response. This is exactly what WireMock allows us to do. It will create a fake HTTP server when we specify we define the specifications with that particular request. If we get a GET call with such URL, then we're going to respond with that status, with such headers, and with that content. Notice that we're using, again, Jackson somewhere there. Repository as JSON actually calls Jackson to encode the list of objects as JSON. And if we get the other URL, that's the next page, then we're going to return with something else, right? So I can show you those tests actually in action. And I just do a clean here, and I'm going to run this. No hands on the keyboard. There are some unit tests happening there. One of them fails. That's okay. And then we see that. That's another library called TestFX, testing the real application. And this is possible because we got a fake server running thanks to WireMock. So I can pull down the network, and the test will still continue to work. And that's basically what I have for you right now for WireMock. There are other libraries out there. There are other testing libraries out there that I couldn't cover in 50 minutes. And just so you know, well, this application doesn't cover persistence, doesn't cover more different sets of communications and protocols. But at least have a look at these libraries. You probably have used some of them. Have a look at the others. You might be able to have better tests or better designs using dependency injection and whatnot. For that, thank you very much. If you have any questions, I'll be happy to take them on the hall because the next speaker is coming up. Thank you very much for your time. Any questions? All right, I guess.